We're going to look at some of the big ideas behind dividing fractions, and hopefully taking a look at these big ideas will make things make more sense so you don't have to just memorize things. So there are many ways that work for dividing fractions. Let's take the fraction 2/3 and divide it by 3/8. Well, one of the ways that we could do it is we could do a crisscross thing where you take the 3 times the 8 going diagonally down and the 2 times the 3, and we will get 24/6, and that happens to be the correct answer. Another way that works is to change the division to multiplication and then multiply by the opposite of the fraction that you were dividing by. And by the opposite, I mean the reciprocal. And reciprocal means the number you would multiply it by to get 1, or you could just flip it upside down. So the 3/2 stays the same times 8/3. Now both these ways work. See, that gives you 24/6, just like the other way. And you might think, well, that has an extra step in it. Who wants an extra step? Well, you might want that extra step, and let me show you why. You might think, hey, why? I don't think there could be a reason. Why would it matter if they both work and one way is shorter than the other way? Well, I was a math teacher for many, many years, and this is one of the things that causes kids to have trouble with math later. Even if you get 100% on everything now, depending on which of those ways you do it, one way you're much more likely to do well later, and the other way you're much more likely to be confused and think math is hard later. So let me show you. What comes later? What are you going to learn later? Well, one of the things that you're going to learn is to solve equations like this. 3/2 equals what over 8? And there's a lot of different ways to do this, but one of the ways that you'll learn is this crisscross, where you multiply diagonally the 2 times the x equals the 3 times the 8. And it doesn't matter which way you do it. You could say 3 times 8 equals 2 times x, or 2x equals 3 times 8. The order you do it doesn't matter which you do first. And if you're dividing your fractions by just multiplying diagonally across, after you learn this, it confuses you on that method of dividing fractions, because it matters which you put on top and which you put on bottom. Here, it doesn't matter what you put on the right or what you put on the left. And these two things are so similar and so similar looking that if you're doing your division of fractions by the diagonal multiplication, after you learn this, it's very easy to get confused. And one of the reasons why it's easy is you don't know why either one of these work. It's just something that you learned, and that happens to work as long as you do it exactly right. You can't really check your thinking because you don't know why this works. So let's look at this. 2/3 divided by 3/8. Now, what comes later in math? The most useful trick in math is multiplying by the number 1 to make the problem that you're doing easier without changing the problem. You can always multiply anything you want by 1, and it doesn't change anything. You can also add zeros, and that's another useful trick. But in this case, the multiplying or dividing by 1 is something you're going to do if you take advanced math, starting with algebra and beyond. You need to know how and to think in terms of, let me multiply by funny versions of the number 1 to make this problem easier. And you can use the ugliest versions of the number 1, which often result in making a problem much easier. So one of the reasons why you would want to use the second method for dividing fractions is it overtly makes use of the fact that you're dividing by the number 1. And so you start to pick up that trick. And here's what I mean by that. The number 8/3 over 8/3, that is equal to 1. Because even though this is ugly, this is an ugly, ugly fraction. It's a fraction over a fraction. But it's still equal to 1 because there's the same thing on top as it is on the bottom. So we're going to rewrite this fraction, and then we're going to multiply it by an ugly version of the number 1. And these steps that I'm showing you here, you don't always go through these steps. I'm just showing you why it works to change division to multiplication and then multiply by the opposite fraction. We can write 3/2 divided by 3/8 as 3/2 over 3/8. Because division you can always write as the first number over the second number, even if they're both fractions. It makes it ugly, but it's mathematically correct. So this problem can be rewritten 3/2 over 3/8. And then once you write it as 3/2 over 3/8, we can multiply by an ugly version of the number 1. And we want to multiply by whatever fraction gets totally rid of that denominator. And the denominator is 3/8. 3/8 times 8/3 is 1, so we can throw it away. So by doing this, this changes the problem into 3/2, which was originally what the number we started with, times 8/3, which is the number, the opposite of the fraction that we started with. So when you cancel out the bottom, which equaled 1, you're left with 3/2 times 8/3. And that's why it works. That's why this method works. To keep the first fraction the same, change divide to times, and then multiply by the opposite of the fraction that you started with. So 3/2 times 8/3. And the reason, and then you could cancel, those 3's cancel, the 2 cancels into the 8. Anything on the top you can cancel with anything on the bottom. And that's working for the same reason. You're just regrouping stuff, so if you line those 3's up, you got 3 over 3, which is a 1, so you can throw it away. And the reason why this way will lead to math being easier for you in the future, because of what comes later. When you learn how to add and subtract with negative numbers, you change subtraction the same way you do with the fractions. You can change subtraction to adding and then make the second number the opposite of what it was. So like 3 minus 5 would be 3 plus -5. That's the same process as changing a fraction to a half divided by 8/3 is a half times 3/8. It's just the opposite with addition versus the opposite with multiplication. And in algebra, you need multiplication. So you don't want to have your problems where you're not going to know what operation it is. You're going through something where you crisscross and flip stuff upside down. You need to actually know what the multiplication problems are, because multiplication is an algebraic property. It's an algebraic operation, and it has algebraic properties. And algebra doesn't make any sense if you can't see what operation you're doing and why. So even though it perfectly works right now to do the crisscross applesauce thing, you're setting yourself up to make math harder if you do it that way now.